Figure 1 shows a part of an experimental setup to determine the relative resistivity rho of material of given wire with the aid of meter bridge. The length of the meter bridge wire AB is 100 centimeters. Part A. The center zero galvanometer has been connected between point C and D to produce the center zero galvanometer. The circuit in figure 2 can be used. Name the type of key K2. K2 should be a plug key. Part A 1 plug key. We are using K2 switch to remove X resistor effectively. We can get approximate balance length when the plug key is turned off, and we are using this X resistor for the safety of galvanometer from a high current. After getting approximate balance length, we can, on the plug key, it means we have to plug the plug key and we can get correct reading when plug key is turned on. X is removing from the circuit because of current is passing through this zero resistance type. Then part 2, select the suitable value for the resistance X from resistors 1, 10, 100 and 1000 ohms. We have to use a large value. Then we can select 1000 ohms as the X resistor. Part B, before taking measurements, how do you check whether the circuit is connected properly? We have to turn on K1 switch and we have to place sliding key. Turn on K1 switch and turn off K2 switch. You can identify K1 is the basic switch in the circuit. When it is turning on, the current is passing through the circuit. When K2 switch is turned off, galvanometer is safe to use. Then we can place sliding key in both ends of wire to check that the galvanometer readings are in opposite side. Then part C, when the resistance value of the resistance box is R, the balance length of the meter bridge wire L in centimeters. Write down an expression for R divided by S in terms of L. Neglect the incorrection of the meter bridge wire. We know that it is like a wheatston bridge. This is the resistance. This one is R. No, this one is R. This one is S. For the balance length, there is no current through the galvanometer. Therefore, we can get resistance of R divided by resistance of this wire part should be equal to ratio between these two resistors. But we know that when considering the resistance of a wire, it is directly proportional to length of the wire. Therefore, we have to divide R by this length and S by this length to obtain the ratio. Then we can write R divided by S. No, R divided by L. R divided by L ratio equals to S divided by 100 minus L ratio. If the balance length is L in centimeters, total wire length is given as 100 centimeters. Therefore, this length should be 100 minus L. Now we have to subject ROS ratio. They have asked ROS ratio. It is L over 100 minus L. Part D. For R equals 9, 26, 56, the balance lengths are 27, 52 and 70 centimeters respectively at 30 degrees. What is the most appropriate value for the R that must be used in order to determine the value of S accurately? Due reasons. Most appropriate value is 52 because of when the balance point is in this side, L value is a small value. When a length is a small value, the percentage error is a higher value. If the balance point is in this end, 100 minus L is a small value. Therefore, we have to maintain the balance point near the midpoint of the wire. Then most suitable reading is 52 degrees, 52 centimeters. We can obtain, we have to write most suitable value of S. Value of S means resistance. We can obtain 52 centimeters when using 26 ohms. Then 26 ohms is the most suitable value for S resistance. Then we have to write the reason, the balance length. The balance length should be near the midpoint of wire. We can't select a small value for L of 100 minus L. Now, part 2, D part 2. Calculate the most accurate value of S using relevant balance length and R. In first part, they have asked appropriate value for resistance R. It should be 26. Then part 2, we have to calculate S value. We can use this 26 value. We can write this relationship. R divided by S equals to L over 100 minus L. We have to use R value as 26 divided by S. Length, balance length is 52 divided by 100 minus 52. Then we can subject S. 26 divided by 52 into 100 minus 52 is 48. 26 divided by 26, 1, 2. 48 divided by 2, 24 ohms. It is the resistance of S. In part E, the value of diameter measured in different places is given in the wire. Places in the given wire are 0.39 millimeters, 0.4 millimeters, 0.4 millimeters and 0.41 millimeters. And the length of the wire is 48 centimeters. Calculate the resistivity of the material of the wire. Before finding resistivity, we have to obtain the mean diameter. Mean diameter is When finding mean diameter, we have to add given 4 values and divide by 4. 0.39 plus 0.40 plus 0.41 plus 0.40 plus 0.4 divide by 4. Then we can get the mean diameter is 0.40 millimeters. Then we can find the cross-sectional area of the wire. Pi r squared. Pi value is 3. It is given in the question. Radius is half of this one. 0.2 millimeters 10 to the power minus 3 square. 3 into 0.04 into 10 to the power minus 6. 3 into 4, 12. 0.12 into 10 to the power minus 6 square meters. Now we can use the equation for resistance when finding resistivity of the wire. We know that R equals rho L over A. We can subject rho R A over L. Then we can substitute values. R means resistance of the S wire, 24. Cross-sectional area is found as 0.12 into 10 to the power minus 6. Length is given as 48 centimeters. We have to convert 48 centimeters to meters, 10 to the power minus 2. Then 24 divided by 24, 1, 2. 0.12 divided by 2, 0.06 into 10 to the power minus 4. We can write it 6 into 10 to the power minus 6. Unit ohms per meter. Sorry, ohm meter. We can get unit by using this equation. It is ohm meter. 6 into 10 to the power minus 6 ohm meter. Now, part F. When the above wire is kept at constant temperature of 100 degrees in an oil bath, for R equals 20 ohm. In the resistance box, balance length is 40 centimeters. Calculate the temperature coefficient of resistance of material of the wire. Now we know that for the temperature given in the question, room temperature is given as 30 degrees Celsius. For 30 degrees Celsius, we have obtained resistance of X at 24. Then I will write it. For 30 degrees Celsius, resistance of X 24 ohms. Now they have given for 100 degrees resistance is 20 ohms. For 100 degrees resistance of S, I will get it as R. They have given balance length is 40 centimeters. Then I will use again the equation we have obtained. R divided by S equals L divided by 100 minus S. Then R value is 20 ohms. Divide by, we have to find X. Equals to balance length 40, 100 minus 40 is 60. Then we can cancel out 20 and 40. Then S value is 60 divided by 2, it means 30 ohms. Now we know that when 30 degrees temperature, resistance of S is 24. When it is 100 degrees Celsius, resistance is 30 ohm. Now we have to use the equation with temperature coefficient of resistance. R theta equals R naught into 1 plus alpha theta. We have to find alpha value, but we have to substitute resistance at 0 degrees for R naught. We don't know the value of resistance at 0 degrees. Then I will substitute at 30 degrees Celsius, it means room temperature. Resistance 24, R naught 1 plus alpha, room temperature is 30. When the temperature of wire is 100 degrees, resistance 30 ohm, R naught into 1 plus alpha into 100. Now there are two equations. We can divide to obtain alpha value. Then dividing, we can cancel out R naught, divide by 6,4, divide by 6,5. Then we can use cross multiplication, 1 into 4, 4, plus 100 into 4, 400 alpha. 5 into 1, 5, plus 5 into 30, 150 alpha. 400 minus 150, 250 alpha equals 1. Alpha equals 1 over 250 per Celsius or per Kelvin. Same value for Celsius and Kelvin because of we have to consider a temperature, a difference of 1 degree Celsius. In part G, for a certain type of material, the temperature coefficient of resistance is the negative around room temperature. Name the type of material. We know that if the temperature coefficient is a negative value, it means resistance is decreasing with temperature. Therefore, it should be a semiconductor. Then we can write answer for part G, semiconductor.